Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will graph a simple log functions. So we're going to start by graphing y equals log base 2 of x. So remember, as we learned in a previous video, this will have an asymptote at x equals 0. X can only be positive. So the way I'm going to graph this is I'm going to use a table of values. You can also make use of your graphics calculator. So I'm going to input x values, but of course I'm only going to choose positive x values because x can't equal 0. It can't be less than 0. So let's choose a number close to 0. So let's say x is a quarter. What would y be? Well, we're saying to what power do you raise 2 in order that you get a quarter? So 2 to the power of minus 2 is equal to a quarter. If x equals 1, y is 0 because 2 to the power of 0 equals 1. Turns out 2 to the power of 1 equals 2, 2 to the power of 2 equals 4, 2 to the power of 3 equals 8, 2 to the power of 4 equals 16, and so on. So now I'm just going to plot each of these points. And now I'm going to join up these points. So this is the graph of y equals log base 2 of x, and it's very typical of graphs of this form. It gets larger pretty quickly, but then the growth slows. It is an increasing function. As the value of x increases, so too the value of y increases, but y just gets larger very slowly in logarithmic graphs. So we see that the x-intercept is 1 because if a is greater than 0, a to the power of 0 is equal to 1. That's why it had this intercept. We also see that x equals 0 is an asymptote, so this graph is going to get closer and closer to the y-axis. The y-axis is the line x equals 0. It's going to get closer and closer to this, but never ever touch. Okay, so how would I graph this function here, y equals log base 2 of x squared? Well, this has a second power that I can just move to the front. So I would get y equals 2 log base 2 of x. So this green graph will be the same as the blue graph, except the y value would be doubled. So it would still have the same x-intercept at 1, but like when y, for example, equals 2, it would now equal 4. Here, where the y value is 3, it would now be up here at 6. And so on. I've plotted more points, so this is what the graph would look like. So you can see here, it has the same basic characteristics. It has the same basic shape. It still gets big quickly and then its growth slows. It's just that the y value is always double that of the blue graph there. Now, this green graph would still have the same characteristics whereby as x gets closer and closer to 0, this will get closer and closer to but never touch the y-axis. So how would I graph something like y equals log base half of x? Well, we learned on the change of base video, we can actually just write this as minus log base 2 of x. So this graph here will look exactly like the blue graph, except I will change when y is positive, it will become negative. So actually this graph will start off big and it will come down. It will still have the same intercept of 1 and then it will get negative and its graph will slow. It will look like that. So for a more accurate picture, you can still use table of values or your graphics calculator. So that's what this thing here is about. When the base is greater than 1, as it was in both these, the graph is increasing. It increases at a decreasing rate. It gets larger and larger and then its growth slows. But if a is a fraction, a number between 0 and 1, like it is here, it actually decays. It starts off decreasing quickly and then its rate of decrease slows. This is a decreasing function. The larger the x value, the lower the y value. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.